Hello everyone. Here's 9.2. Solve quadratic equations by completing the square. So not in every case will you be able to directly solve by using the square root property, which was 9.1. But in every case, you will be able to kind of adjust so that the square root property can be used. And that's what this completing the square routine is about. We're gonna see a problem where initially we can't isolate something squared, but then after we complete the square, and that's why it's called complete the square, is because we're gonna do some algebra to create something that does get written as something squared. That way we can then again use the square root property. So completing the square is a new technique, but really it just gets us back to the old technique. So we approach a problem. If we can't isolate something squared to begin with, then we can use this completing the square process to achieve something squared equals a number. So what it says, and I'll read this, but it does become a little confusing without doing an actual problem, which we'll do here. But it says, if you can identify x squared plus bx in your problem, then if you add b over 2 squared, and this b here is the same as this b, so if you add half of b squared, then you get something that's now factorable. So if you literally add half of b squared to x squared plus bx, now you can rewrite that thing as something all squared, and then you can use the square root property. So in our problem, this example 1, part 1, this right here is x squared plus bx. So this is our x squared plus bx in this case, right? That's what is mentioned here. So in other words, our b is this number 4. So what I'm going to do is find half of b squared. All right, so I'm going to use this approach. So b for this problem is 4. That means that half of b squared would be 4 over 2, which is 2 squared, which is actually 4. And 4 is the only number that does that besides 0, where half of itself squared is itself. So what I'm going to do is now add that in. What this says is to then add half of b squared in. So I'm going to add it in there. So we'll have x squared plus 4x plus 4, right? That's that number that I'm bringing in. I still have minus 1, so I'll have minus 1, and I still have equals 0. But what just happened was I just added 4 to the left-hand side of the equation, right? Here's a 4 that's on the left-hand side that wasn't there originally. So whenever I add something to one side, I also need to add it to the other side. So since it was a 4 in this case that I added to the left, I also need to add a 4 to the right just to balance it, just like we always do with equations. So now this trinomial is a perfect square trinomial. Now it factors as something all squared. So this thing should now factor as something squared. All right, so we have a 4. 8 times c is 4, and then I want to actually add up to a 4 as well. 2 and 2 do this. So I can quickly write down the factorization since I have a 1 for a. So I can say x plus 2 times x plus 2 minus 1 equals 4. X plus 2 times x plus 2 is the same as x plus 2 all squared. And then I'll just keep the negative 1 equals 4 for now. All right, so now we have something that is all squared and it fully contains our variable x. So add 1, I want to isolate that thing that's being squared. Right, now we're back to a problem like we had in the previous section. So apply a square root, plus and minus on the pure number side. So I have x plus 2 equals plus and minus root 5. And finally subtract 2. So I have x equals, excuse me, negative 2 plus and minus root 5. So two solutions there. One of our solutions is x equals negative 2 plus root 5, and the other one is x equals negative 2 minus root 5. So you could write it either way. This just captures both in one, and this just splits them up. Let's try another one. This completing the square process seems like a lot at first, and it is a lot at first. So I don't want to downplay it. But with practice, it'll become less and less confusing, just like maybe anything else that we do. All right, so in our case here we have, this is again x squared plus bx. So for us, b is actually negative 20. Right, it's that number that's attached to the x term, right? b is always attached to x. So since negative 20 is attached to x here, negative 20 is b. So now I need to find half of b and square it. So negative 20 over 2 squared. This is negative 10 squared, in other words, 100. So I will add in 100 over here. Right, and just like I eventually added the 4 to both sides, I do need to add this 100 on both sides. So we'll have x squared minus 20x plus 100 equals 21 plus 100. So now this should be a perfect square trinomial. So if we factor it, we're looking for 100. We want to multiply to 100 and add up to negative 20. So negative 10 and negative 10 do that. Notice for the perfect squares, they're always going to be the same number. Right, same number for these perfect squares. So that you should expect that. So in other words, we have x minus 10 times x minus 10 equals 121, right? 21 plus 100. So that would be the same as x minus 10 all squared equals 121. And now we're back to the square root. So apply a square root to both sides, plus and minus. So x minus 10 equals plus and minus 11, which is the square root of 121. Then finally add 10. So x equals 10 plus and minus 11. So in other words, take 10, add 11. So I get x equals 21 as one of our solutions. And x equals also 10 minus 11, so negative 1. And keep in mind, I'm kind of skipping the check step, but you can check all these. You can plug 21 back in. You can make sure that we get 21 equals 21. I'll just do that real quick since 21 is kind of a strange answer. 21 squared minus 20 times 21 is 21. Hopefully you can see that. try another one. So what that process was saying is if you can identify x squared plus bx, and then if you add in half of b squared, that'll always factor as x plus half of b all squared. That's what's in that definition on the previous page. So I need to identify x squared plus bx. That's kind of step one. I don't have x squared alone, right? I have 2x squared. I don't want a 2, I don't want anything besides a 1 as my coefficient on x squared to be able to carry this process out. So what I'll do is divide out that 2. So I'll divide everybody by 2. So x squared plus 3 halves x minus 2 equals 0. So this now is my x squared plus bx. So in other words, b is 3 halves. It's this fractional b in this case, but everything else is the same. Need to find half of b squared. So that's 3 halves over 2 squared. So that would be the same as 3/4 squared. In other words, 9/16 is half of b squared. So 9/16 is the number I'm going to add in right there, but also over here, right? What I do to one side, I have to do that same thing to the other side. So this will become x squared plus 3 halves x plus 9/16. And then I'm just kind of scooting that -2 out of the way. So it's still there, the -2, but I'm kind of bringing this 9/16, just squeezing that in front of it. And then this equals 0 plus 9/16. So now this trinomial should factor, and it should factor as x plus half of b all squared. Half of b, right, is right here. I'm going to factor this one a different way. So half of b is this number, which is this number right here. Right, the formula says it'll always factor as x plus half of b. So x plus half of b, this should be the factorization of this. I still have -2 equals 9/16. Okay, so what I did there is instead of factoring with the a times c method, is I factored just using the conclusion here. Let me just bring your attention back for a second. Okay, so here when I factored, right here at this step, I did my a times c approach, right? And I factored, I eventually got this. But it's true that these things will always factor this way. It'll always be x plus whatever b was over 2 all squared, right? Check this out. That 2 right there is exactly half of b, because b is 4. So it's no coincidence that if b is 4, I get half of b right there. That's what this is saying. Half of b will just appear right there in the factorization. For the next one we did, I factored using the a times c method, but I could have used this conclusion that said it'll always factor as x plus half of b. B in this second case is -20. Half of b would be -10. And you can see that -10 right here in our factorization, right? So here's half of b. Since b is -20, half of it is this -10. I factored it using a times c, so you can do that. For the one I have now, I have fractions. So a times c would be a little confusing maybe. So that's why I'm using this conclusion here. So it'll always just be x plus half of b, In my case, b is 3/2. Half of 3/2 is 3/4. So continuing, add 2. We want to isolate this thing that's being squared. Don't forget about your friend the calculator. So 9/16, and then I'm adding 2. I can just quickly do that here. That's 41/16. So I'll have x plus 3/4 all squared equals 41/16 square root, plus and minus. Don't forget about that. X plus 3/4, right? This cancellation occurs, equals plus and minus the square root of 41. No simplification happens there, but the square root of 16 is just simply 4. So I'll just write 4 down there. Finally, subtract 3/4. So I have x equals -3/4 plus and minus root 41 over 4. Okay, so apparently those x's, and just to split them up, what I mean by those is one of our answers is -3/4 plus root 41 over 4. And the other answer is x equals -3/4 minus root 41 over 4. So that's what I mean by those answers. There's really 2 packed into here. I'll leave number 4 open. I'll go on to page 108. So part 5, we have kind of definitely something to not do would be to set x plus 6 to 9 and x minus 2 equal to 9, right? There's no 9 product property. It'd only be true if there were a 0 over here. So if this were a 0, then I would just have, yeah, x plus 6 needs to be 0 or x minus 2 needs to be 0, but it's a 9. So we need to go a different route. What I'll try is FOIL. X times x is x squared. X times -2, -2x, 6 times x, plus 6x. And then the last term we have a -12. This all equals 9 still. So I'll subtract over this 9, perhaps. So I'm getting x squared plus 4x minus 21 equals 0. So I'm noticing that this one might actually factor, right? If you can do this, I think you can do this by factoring. I'll just solve this by completing the square. So let's say I didn't notice that it factored. So this is x squared plus bx. So for that reason, b would be 4. Half of b squared would be 4 over 2 squared. In other words, 2 squared, which is 4. So that would be the number I'll add in here, and I'll also add in over here. All right, so x squared plus 4x plus 4 minus 21 equals 0 plus 4. So now this trinomial should factor, and it should factor as x plus half of b all squared. So x plus half of b all squared minus 21 equals 4. So I can factor it that quickly. Isolate x plus 2 all squared, right? We want to isolate the thing that's being squared so that we can apply a square root. So add 21. So x plus 2 squared equals 25. Square root plus and minus. So x plus 2 equals plus and minus 5, right? The square root of 25 is 5. And then subtract 2. So x equals negative 2 plus and minus 5. In other words, x equals 3, right? Negative 2 plus 5. And then also x equals negative 2 minus 5. So x equals negative 7 as well. And you can find those answers actually by factoring right here. You could factor this. Get those same ones if you want. Okay, on to page 109. I'm leaving part 7 open. Of course, I'll attach solutions next to the video. All right, so part 8 is an important problem. It looks quite different than the ones we've done. The main difference is that we just have A, B, and C rather than numbers. But A, B, and C are just meant to be numbers. And what I'm going to do is solve this one by completing the square. And that'll kind of get us a nice way to the next section. And we'll see what's going on in that next section by the end of this problem. So let's say I just use the same approach, right? I want to develop an x squared plus bx. So I need to divide everything by a first. Okay, so I'll have x squared plus b over a x plus c over a equals 0. So right here is our x squared plus bx. And weirdly, b is actually b over a, right? It's this number here. So half of b squared would be b over a over 2 squared. In other words, b over 2a all squared. In other words, b squared, if I square everything, over 4a squared, right? B squared, 2 squared is 4, a squared is a squared. So this is half of b squared. So this is the thing that I'm going to bring in right here and also over there. So what we're doing right now is exactly what we've been doing, but just in general now. So we're performing the same steps, except now we just have A, B, and C rather than actual numbers there. Okay, so what we now have is, let's see, x squared plus b over ax plus b squared over 4a squared. Right, so I've just put that here, and then I still have plus c over a, and then this is equal to 0 plus b squared over 4a squared. Right, so that was just adding in half of b squared. So now this thing is our perfect square trinomial, and it will factor as x plus half of b all squared. So x plus half of b is right here before we squared it, right? This is half of b right there. So x plus half of b is x plus b over 2a all squared. This is now plus c over a, right? We still have c over a there, equals b squared over 4a squared. So now here we are. I want to isolate this thing so that I can apply a square root. So I'll subtract c over a from both sides. So I'm going to bring all this up here now. So that will create x plus b over 2a all squared equals b squared over 4a squared minus c over a, right, from subtracting that c over a. Before I take the square root, I'm actually going to get these things together. So a and 4a squared, to get the same denominator, I need to multiply by 4a over here, so that I have a 4a squared in both denominators, right? I have a, so if I multiply by 4a squared, I'll have 4a squared. So x plus b over 2a all squared equals b squared over 4a squared minus 4ac over 4a squared. Now I can actually combine these. So I can say x plus b over 2a squared equals b squared minus 4ac over 4a squared. Right, just combining these into the same fraction because they have the same denominator. Now, finally, square root plus and minus on the side with the pure number, which this would just be a pure number based on a, b, and c. So these cancel. I have x plus b over 2a equals plus and minus the square root of b squared minus 4ac all over 4a squared. In bottom, I have 4a squared, so I can actually simplify that. The square root of 4a squared would just be 2a. So x plus b over 2a equals plus and minus the square root of b squared minus 4ac. Sorry, and I was just going to put all this now over, the square root is only up top now, over 2a outside of the square root. There's a lot going on, I realize. Okay, so minus b over 2a, minus b over 2a. I'm isolating x because we're about to solve for x finally. So x equals negative b over 2a, right? I subtracted that over. So now it's over here. Plus and minus the square root of b squared minus 4ac over 2a. And since these have the same denominator, I can actually bring these together as one fraction. So in other words, x, our solutions to this original problem, right? The solutions literally to this original problem would be x equals opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So what's great about that is that this is actually a formula now that you can use to solve any quadratic equation. Because what we just did is we solved a general quadratic equation, and what we've developed is something called the quadratic formula. And you can use this formula for any quadratic equation. Okay, and keep in mind this is the square root. It goes all the way over. The next section is all about solving quadratic equations using the quadratic formula. So this is why I saved this problem for the end, because this is where the quadratic formula comes from. It comes from, solving a quadratic equation in general by completing the square. So if you were familiar with this quadratic formula, but you just didn't know where it came from, now you have a better sense of where it comes from. If you solve by completing the square, this general equation, what you end up with is the quadratic formula.